March 29th, 2024. Good Friday. Andres Freund, a Microsoft engineer in San Francisco, is debugging PostgreSQL. He runs an SSH login. It takes 0.5 seconds longer than expected. Half a second. Most people wouldn't notice. Most people who noticed wouldn't care. Andres Freund investigated. What he found? A backdoor. Planted over 2 years. Hidden in compression software that runs on millions of Linux servers worldwide. Remote code execution. Complete system compromise. Designed to be invisible. It was weeks away from being deployed to production systems globally. If Andre hadn't been curious about half a second, banking systems, compromised. Government servers, accessible to attackers. Cloud infrastructure, backdoored. Corporate networks, wide open. Millions of servers, running what appeared to be legitimate, trusted code. With a secret backdoor allowing remote access to anyone who knew it was there. The attacker had been patient, professional, nearly invisible. They spent 2 years building trust, contributing code, pressuring a volunteer maintainer who was burning out. And they almost succeeded. This isn't a story about hackers in hoodies. It's about something more frightening. How much of the internet's critical infrastructure is maintained by unpaid alternatives? How patient attackers exploit that reality. And why one engineer's curiosity about 0.5 seconds prevented what could have been the biggest supply chain attack in history. This is the XZ Utils backdoor. The attack that almost worked. Let's investigate. First, understand what XZ Utils is. It's a compression library, software that makes files smaller. You've used compression, ZIP files, JPEGs, MP3s. Compression algorithms find patterns in data and represent them more efficiently. XZ Utils uses the LZMA compression algorithm, one of the most efficient methods available. It's everywhere in Linux systems. Software package distribution, system backups, log file compression, kernel module compression. If you use Linux, you use XZ Utils, often without knowing it. Here's the thing about infrastructure software. It's invisible until it breaks. XZ Utils is in the dependency chain of thousands of packages. Major Linux distributions, Debian, Fedora, Ubuntu, Arch, all include it. When you install software on Linux, package managers automatically unlock dependencies. XZ Utils is often one of them. This makes it a perfect target for supply chain attacks. Compromise one widely used library, and you potentially compromise everything that depends on it. Now here's the critical detail. XZ Utils was maintained by one person, Lasse Collin, a Finnish developer, unpaid volunteer. Maintaining critical infrastructure used by millions. He'd been doing this since 2009. 15 years of unpaid work, fixing bugs, reviewing contributions, responding to issues. This is common in open source. Critical libraries maintained by individuals or tiny teams. No funding, no support staff. Just developers who care enough to keep things running. This isn't a criticism of Lasse. It's the structural reality of how the internet works. And attackers know it. 2021. A new contributor appears on the XZ Utils project. Username: Jia Tan. Jia Tan 75 on GitHub. Their early contributions were legitimate: bug fixes, performance improvements, code cleanup. They were professional, responsive, helpful. Over months, Jia Tan built credibility. They understood the codebase. They fixed real issues. Lasse Colin, the maintainer, was grateful. Open source projects desperately need contributors. But Jia Tan wasn't real. Analysis after detection revealed activity patterns inconsistent with claimed time zone. Writing style suggesting non-native English speaker, contradicting supposed background. Coordination with other suspicious accounts. No verifiable real-world identity. Jia Tan was a persona, a sophisticated fake identity designed to gain trust. 2022. Other accounts begin appearing in XZ defendants' discussions. They complain about slow development. They question Lasse's responsiveness. They suggest the project needs more maintainers. Example complaints: "This project is blocking important work. The maintainer seems unresponsive. We need more active leadership." These weren't legitimate concerns from frustrated users. They were coordinated pressure. The accounts were connected. They appeared during specific windows. They amplified each other's concerns. The goal? Make Lasse Colin feel inadequate. Make him want help. Make him trust contributors who seemed capable, like Jia Tan. It worked. 2022. Lasse grants Jia Tan commit access. Not full project control, but significant authority. The attacker was now inside. Over the next 2 years, Jia Tan methodically planted the back door. Not in one obvious commit. That would trigger review. Instead, gradual changes across many commits. Tests that looked legitimate but included suspicious binary blobs. Build script modifications disguised as improvements. Code refactoring that created opportunities for exploitation. The back door wasn't in the source code itself. It was in the build process. The scripts that compile source code into executable programs. This is sophisticated. Source code audits wouldn't catch it. You'd need to analyze the build artifacts. What the backdoor did, it targeted OpenSSH, the software handling remote server logins. On systems using the compromised XZ library, the backdoor could intercept SSH authentication, allow bypass with a secret key, execute arbitrary code with system privileges. An attacker with the secret key could connect to any vulnerable server and gain complete control. No password needed, no logs. And because XZ Utils is a compression library, something SSH uses indirectly through other dependencies, the connection wasn't obvious. It was elegant, patient, nearly invisible. And it was about to ship to stable releases of major Linux distributions. March 29, 2024. Andres Freund is working on PostgreSQL performance. He's profiling system calls, measuring performance, standard debugging. He notices SSH logins are slower than expected. 500 milliseconds slower, half a second. Barely noticeable in normal use. But Andres wasn't doing normal use. He was profiling, measuring, comparing. And something about it bothered him. Andres digs deeper. He uses Valgrind, a profiling tool that tracks program behavior. He finds libelzemma, The XZ compression library is being loaded during SSH authentication. That's weird. SSH doesn't directly use liblzma. Why would a compression library be involved in authentication? He checks the binary, compares it to previous versions. The file sizes don't match. The latest version of liblzma.so is larger than it should be. The difference? About 700 kilobytes. Something is hidden in that binary. Andres extracts the binary, analyzes it. He finds obfuscated code, hidden functions, data that shouldn't be there. This isn't a bug, this is intentional. He posts his findings to the OSS security mailing list. Subject: Backdoor in upstream XZ/liblzma, leading to SSH server compromise. The response is immediate and alarmed. Within hours, security researchers worldwide are analyzing the backdoor. What they find is sophisticated. Layer 1. Test file injection. Jia Tan had added test files to the repository, supposedly for verifying compression. These files contained binary data that looked like compressed test data. They were actually components of the backdoor. Layer 2. Build script modification. The build scripts were modified to extract and execute code from those test files during compilation. The modification was disguised as M4 macro improvements, technical changes that look legitimate. Layer 3. Function hooking. The backdoor hooked into the authentication functions of OpenSSH. It intercepted login attempts and checked for a special signature. If the signature matched, it bypassed authentication and provided a shell. The forensic timeline. October 2021. Jia Tan account created. January 2022. First contributions. January 2022 to June 2022. Pressure campaign on maintainer. June 2022. Jia Tan granted commit access. February 2023. First suspicious commits. February 2024. Final backdoor components added. March 24, 2024. XZ Utils 5.6.1 released with full backdoor. March 29, 2024. Andres Freund discovers anomaly. Critical detail. The backdoored versions, 5.6.0 and 5.6.1, were in testing/unstable branches of major distributions. They hadn't reached stable releases yet. Andres found it with weeks to spare. If he'd waited another month, millions of servers would have been compromised. Let's understand the potential impact. Systems that would have been vulnerable. Fedora 41, testing branch. Debian SID, unstable. Arch Linux, bleeding edge. Various rolling release distributions. From there, cascading to enterprise Linux systems, weeks later. Cloud providers, Amazon Linux, Google Cloud, etc. Embedded systems, IoT devices running Linux. What an attacker could do. Mass surveillance. Monitor traffic on compromised servers. Data theft. Exfiltrate sensitive information. Ransomware deployment. Encrypt systems for profit. Botnet creation. Use servers for DDoS attacks. Persistence. Maintain access even after system updates. And, because the backdoor was in authentication, it would be nearly invisible to traditional monitoring. The obvious question: Who did this? We don't know for certain. Attribution in cybersecurity is hard, but the evidence suggests not amateur hackers. The sophistication level, multi-year social engineering, deep technical knowledge, patient execution, suggests significant resources, likely state-sponsored. The target, SSH on Linux servers, and methodology align with nation-state attack patterns. This attack required deep knowledge of build systems and binary formats, social engineering expertise, patience, 2+ years. No obvious financial motive, not ransomware, not cryptocurrency theft. These characteristics suggest an intelligence operation aimed at long-term access to critical infrastructure. But naming a specific country would be speculation. What matters? This type of attack is happening. And it will happen again. Here's the uncomfortable truth about how the internet works. Critical infrastructure is maintained by unpaid volunteers. OpenSSL, securing most of the internet's encrypted traffic. Small team. Curl, transferring data in millions of applications. One primary maintainer, Daniel Stenberg. SQLite, database in billions of devices. Tiny team. Log4j, remember the 2021 vulnerability? Volunteer maintainers overwhelmed. These aren't obscure tools. They're fundamental infrastructure. Imagine being Lossa Collin. You maintain critical software, used by millions, for free, in your spare time. You have a day job, a life, limited time. Someone offers to help. They seem capable. They fix bugs. They're professional. Of course you accept their help. This isn't a failure of judgment. It's a structural problem. Tech companies build billion-dollar businesses on open-source infrastructure. How much do they pay the maintainers? Often, nothing. Example: a Fortune 500 company runs software depending on XZ Utils. Their revenue? $50 billion annually. Their contribution to XZ Utils maintenance? $0. This isn't universal. Some companies fund open source. Google, Microsoft, and others have programs supporting critical projects. But the default model? Extractive. Take the code. It's free. Build products. Profit. Don't fund maintenance. After the XZ backdoor discovery, conversations accelerated. The Open Source Security Foundation increased funding for audits. Linux distributions discussed better code review processes. Proposals for paying maintainers of critical infrastructure. But systemic change is slow. Let's be clear. We got lucky. If Andres Freund had not been profiling that specific system, not noticed 0.5 seconds, not been curious enough to investigate, waited 2 more weeks to investigate, the backdoor would have reached stable releases. Millions of servers would have been compromised before anyone noticed. Detection might have taken months or years. The attacker would have had silent access to critical infrastructure globally. We don't have a robust system for preventing this. We have curious individuals. And luck. That's terrifying. But something did work. Open source transparency. The backdoor was sophisticated, but because the code was open, anyone could investigate anomalies. Andres wasn't part of XZ development. Binary comparisons were possible. Closed source software hides this. Community collaboration accelerated analysis. Global researchers contributing. Rapid patching. Within hours, fixes were distributed. If XZ Utils had been closed source, The anomaly might have been undetectable. Forensic analysis would be impossible without internal access. The vendor might have covered it up. Fixes would take weeks to coordinate. Open source's transparency is a security feature, not a bug. But it's not enough. Immediate actions after discovery. March 29, 2024. All major Linux distributions rolled back to safe XZ versions. Security advisories issued globally. Forensic analysis began. Following weeks, full audit of XZ Utils codebase, review of Jia Tan's contributions, all commits examined. Implementation of additional security checks in distribution build pipelines. Last Colin received support from Linux Foundation. Importantly, no blame was placed on Last Colin. The community recognized he was targeted. He did nothing wrong. He was a victim of a sophisticated attack. But here's the hard truth. This will happen again. The XZ backdoor wasn't unique. It was just the one we caught. Supply chain attacks are increasing. 2020. SolarWinds. Compromised software update affected 18,000 organizations. 2021. Log4Shell. Critical. Vulnerability in logging library. 2021. CodeCov. Bash uploader backdoor. 2024. XZ Utils. Nearly successful backdoor. Each time we say, we need better security. Then we move on. Until the next one. Real solutions require structural changes. 1. Fund critical infrastructure maintainers. Pay people to maintain code that billion-dollar companies depend on. 2. Security audits at scale. Regular, funded audits of widely used libraries. 3. Better code review processes. Multi-party review for commits to critical projects. 4th. Supply chain verification. Cryptographic attestation of build processes. 5. Reduce maintainer burden. Distribute responsibility. No single person critical projects. None of this is cheap. All of it is cheaper than a successful supply chain attack. The question is, will we invest before catastrophe or only after? March 29, 2024. Andres Freund noticed SSH was 0.5 seconds slower. He could have ignored it. It was barely noticeable. He had other work. He investigated anyway. Somewhere right now, another patient attacker is building trust in another project, creating fake identities, contributing legitimate code, waiting for commit access. Somewhere right now, another volunteer maintainer is burning out, grateful for help, unaware they're being targeted. Somewhere right now, another critical library has vulnerabilities no one has time to fix. The XZ Utils backdoor teaches us. The internet runs on trust. Open source relies on assuming contributors are honest. Trust can be weaponized. Patient attackers exploit that assumption. Curiosity saves systems. One person noticing one anomaly prevented catastrophe. We like to think the internet is built on cutting-edge technology, advanced algorithms, corporate infrastructure. The truth is less reassuring. It's built on volunteer developers, maintaining code in their spare time, with limited resources, under constant pressure. And it's defended by people like Andres Freund, curious about half a second. This is Cosmic Canvas, where we investigate the invisible infrastructure our world depends on. Until next time, update your systems, support open source maintainers, and pay attention to anomalies. You might just save the internet.